Debugger allows you to debug your C# code while the Unity entity is in the play mode. You can attach breakpoints within the code editor in order to inspect the state of your script code and its current variable at runtime. Open the preference window and go to General tab, and there you switch code optimization on startup from release to debug. The release mode disables C# debugging but improves C# performance. Switching to release mode will recompile and reload all the scripts. But now we have switched to debug mode. Close the preference window. Using this debug icon that is at bottom right corner, using it we can easily switch between release and debug mode. And it also gives you the tip regarding the switching mode. As we switch to any mode, the very last icon is start circling. It shows us it's recompiling and reloading all the scripts. And now quickly I have created a debug example game object and also attached a debug example script and wrote a basic script to test the debugging. It's a very basic script to swap two values. We have a value A and B. We will print the value A and B, then we will swap these values and then again we will print them. It's not a correct solution, but the point is we will debug it to make it right. Switch back to Unity and enter the play mode, and let's see what we have in the console. Opening the console window to view the debug values. In value A we have 5, value B 10, and after the swapping we have value A 10 and value B 10. But we will be expecting value B should be 5. Here our purpose is just to understand the debugging with the most basic example. Exiting the play mode. The first thing we are going to do while selecting the script game object, click on these three dots and select the debug. It will expose the private variable of our debug example script. So now we can see the value A and B. Let's enter the play mode again and keep an eye on the debug inspector on value A and B. As the code compiles, it replaces the both variable with the value 10. Next, we are going to use breakpoints as it's not enough to identify the problem. In the code editor, set a breakpoint where you want the debugger to pause the execution. Simply click over the left margin area where you want to toggle a breakpoint. A red circle appears next to the line number of highlighted line. We added a breakpoint at our logic, as at this area the values are swapping. Switching back to Unity and enter the play mode. As the project will start, it will stop the execution at the breakpoint. It will take us directly to the dead line of code. The execution is stopped for investigation and we are in the Visual Studio. The first thing we can see the values by hovering over variables, and it's really nice to have this feature. At the bottom in the watch window, you can also add a specific values to track. One way is click on this plus sign and enter the variable name, and it shows us three columns: name, value and type. So the execution is at line number 13 and in the value A we have 5. Right click on any variable and select add to watch to add any variable to the watch. It's an alternate way of adding a variable to the watch window. At this point the value A is 5 because this line is not executed yet. Click step over to execute and go to next line. After the execution of line 13, value B is assigned to value A and now A and B is 10. So now we have identified the fault is at line number 14, as we were expecting to assign 5 to the value B. But we are assigning a 10 to the value B, that is already the value of B. So what we need to do is to hold the value of A temporarily before assigning the value of B to the A. At the first line, assign value A to the temp value. Assign the variable value B to the variable value A. This time before replacing the value of A, we are holding the value in the temp value. Next, assign the temp value to the value B. The temp value is actually a value of A. So basically we are assigning the value A to the value B. Keeping the breakpoint at line number 14, it's the first line of our logic. Back to Unity and enter the play mode. Step over to next line. Hover the cursor over the temp value to see the value of the temp value. We stored A in the temp value. Step over to next line. Value A is replaced with 10. Step over and next we will be replacing value B with 5. So now we successfully replaced the values of the both variables. You can stop the debugging using this stop button. You can remove the breakpoint by right clicking on it and select remove breakpoint. Switch back to Unity and enter the play mode. This time it won't stop the execution. Open the console window to view the debug values. And here we can see the expected swap values. Using Visual Studio, you can directly enter the play mode. Select your breakpoint and click here to open the list and select attach to Unity and play. This way you don't have to switch to Unity every time to enter the play mode. You can directly play it from the Visual Studio by clicking at here. It will enter the play mode and stop the execution as we are expecting. And as usual, we can use the step over to execute and go to next line. Next is searching. We can search a specific variable in the script by going to a search menu and click find. It will highlight this variable at all the points and we can use these arrow buttons to navigate them. You can also quickly replace the specific variable by going to search and replace. And here you can add the variable you want to replace. I'm typing value AA. And press the replace button. I'm pressing Ctrl Z to undo this replace action. Open the search menu and click on find in files. Using this option you can find the specific variable from the whole solution, or you can select the other option from this look-in list. Let's try the whole solution first. That was the default. Click on find. It's searching the whole solution and it's giving us where the value A is used. In this project we are only using in the debug example. Click on these three dots and select open editor log. You can use this debug window to view the logs of the Unity editor. Enter the play mode and the logs will popping up in this window. These logs are especially helpful when your game is freezing or it's crashing. Mostly we are using debug.log, but we also have a debug.log warning and .log error. Log warning is used for warning messages and log error for the error message related. Enter the play mode and open the console window to view these messages. And by pressing these buttons, you can filter the different type of logs. By pressing this log button, it will hide all the logs and it will hide all the warnings and all the errors. And that's how you can filter the different logs. Next we have debug.drawArray. To demonstrate it, I have quickly set up the scene. Created a bunch of cubes and attached them example class script. And these cubes will be raycasting to detect anything. Open the script and that's our basic raycast script. At line number 10 we are casting the ray in the forward direction, and if it will hit something it will print did hit. Switch back to Unity, enter the play mode and open the scene window. As we can in the scene window we have no visuals regarding the raycast. This way it's very hard to know what's going on with the raycast. We have the option to add the visuals for debugging the raycast. Going back to script and adding debug.drawArray. In the drawArray we are passing the position, direction and a color. The line will have a yellow color when it will hit something and the white color when it hit nothing. Going back to Unity, Keep in mind these lines only shows in the scene view. And these lines are showing us the raycasting of the cubes in a forward direction. The cubes with the white lines are not hitting anything. And the cube with the yellow line are hitting on something. These draw lines are updating real time. You can move around the cubes to view their action. And of course we can also change their rotation as well. It's a basic example, but in a very complex game it is very helpful. If you are facing issue in your project, it's almost impossible to understand the bug without these things. Every developer should have a strong grip on the debugging. If you only want code to run when development build is enabled, you can check if debug.isDebugBuild returns true. As in summarizing this video and the other tips, Unity includes a debug class to help you visualize information in editor while it is running. Use it to print messages or warnings into the console window. Draw visualization lines in the scene view and game view, and pause play mode in the editor from the script. You can pause the execution with debug.break. This is useful if you want to check certain values in the inspector when the application is difficult to pause manually. You should be familiar with the debug.log, log warning, and log errors for printing console messages. Also handy is debug.asserts, which asserts a condition and logs on error on failure. Only works if Unity assertion symbol is defined. Next is when using a debug.log, you can pass an object as a context. If you click on the message in the console, Unity highlights the game object in a hierarchy window. Next is you can use rich text to mark up your debug.log statements. This can help you enhance the error reports in the console. And the next tip is Unity does not strip the debug logging API from the non-development builds automatically. Wrap your debug log calls in custom methods and decorate them with the conditional attribute. And removing the corresponding scripting defined symbols from the player settings compiles out all the debug logs at all once. This is kind of identical to wrapping them in a hash if and if preprocessor blocks. And next is regarding the troubleshooting physics. Debug.drawLine and debug.drawRay can help you visualize the ray casting. And the last tip is use application.setStackTraceLog type or the equivalent checkboxes in the player settings to decide which kind of log messages should include in the stack trace. Stack traces can be useful, but they are slow and generate garbage. You should have a strong debugging skills to have the maximum performance of your project. I hope this video helps you. If you have any question, you can always ask me. Thank you for watching, and I see you in the next.